Hello everyone, welcome to another one of my Leetcode videos, and this one we'll do Leetcode 2583, kth largest sum in binary tree. This was also part of today's contest. So let's get right into it. Basically, we're given the root of the binary tree, and we have to determine the kth largest level sum, right? So in this case, each level has a sum, and we're given an integer k. So if it's k is 2, then we need to find the second largest sum. If k is 3, we need to find the third largest sum, and so on, right? So what will be our approach to solve this problem? Basically, obviously we need to calculate the sum of each level, right? So once we calculate the sum of each level, what do we do with those sums, right? So since we need to calculate the kth largest, right? So we'll use a priority queue, because usually priority queue is a good data structure to keep track of, like, what's the largest so far, right? So in our PQ, we'll keep inserting all of the sums, right? S1, S2, S3, and so on. And then if the size of the PQ exceeds k, right? Let's say there's like 20 levels and we only need the third highest, right? So let's say now we put the sums of 3 levels and we got the fourth level, right? So what we'll do is, if we'll insert the fourth level and then we'll take out the smallest one, right? So let's say the smallest one in the PQ happened to be S3, so we'll take this out. So at each point, we'll have the top 3, if k is 3, or the top k in the priority queue, right? And at the end, we'll return the smallest element in the queue, because that was the kth largest, right? We don't return the biggest one because that's the biggest overall, right? We want the kth biggest. So the smallest one in the top k will be the kth biggest. So let's go ahead and code that solution and see how that looks like. So first we'll create our priority queue. So that's our priority queue, and at the end, right, it also says if there are fewer than k levels, then we just return -1, right? So if pq.size is less than k, then we just return -1. Otherwise, we return pq.poll, that's the smallest element in the priority queue, right? And so now we just have to populate, all of the sums of the levels, right? So this is just basically going to be a level order traversal, right? So it's similar to a BFS, right, where we have the first level and then we add all of the children of everyone in the first level to the next level and keep going until there are no more levels, right? So we'll start with our current level, right, equal to a new array list, and the first level will just be the root, and we're guaranteed that we'll have a root because it says there will be at least 2 nodes in the tree. So we'll add the root to our list of current levels, and this should be tree node. And so while current level is not empty, we'll keep going until we have a level, right? And in here, other than computing our sum, we'll also be computing the next level, right? So we'll keep adding the children of the current level to the next level, and at the end, when we're done processing, we'll set current level equal to next level, right? So that's the standard like BFS type of algorithm. So now that we have this set up, we'll pull out everything from the current level, right? So we'll do another loop here saying while not current level dot is empty, we'll say, okay, int or tree node is equal to current level dot poll. So this will give us the node, and what we want to do is we want to keep track of our level sum equals 0, right? And so what we'll do is we'll say level sum plus equals node dot val. So that means we're keeping track of the sum of this level, and at the same time, if it has any children, right? So if node dot left is not null, then we'll add node dot left to our next level, right? So we can go and compute the sum of our next level, and we'll do the same thing for node dot right. So here we have it for node dot right as well. We're adding it to the next level, right? And at the end, we'll have current level equals next level, so it'll go and compute the sum of the next level. But now what do we do with our sum? So let's just go ahead and add the sum to our priority queue, right? But then also remember when we said if the length of the priority queue exceeds k, right? So if it's greater than k, then we don't need, you know, the smallest one anymore because we're only interested in the top k, right? So then we'll just say pq.pull. That will remove the smallest one from the priority queue. So hopefully this should do it. Let's run it and see how this does. All right, instead of using lists for the level, I should be using queue because apparently we don't have a poll function in lists, obviously. So I'll just go ahead and change all of the current and next level to queues. All right, accepted. Let's submit. Okay, wrong answer because we forgot to take care of the overflow case. So note that we have to return long and the sum can exceed integer bound. So let's just change the sum to long and see how that does. Oh, since the sum is now long, we also need to change our priority queue to long because that's where we're adding the sums. Okay, this time accepted. Thanks so much for watching. I'll see you in the next video. Cheers.